So what we want to do is kind of get back to where we started things off about solving triangles. So what we're going to be looking at is we're going to be looking at oblique triangles, and oblique triangles are triangles that do not contain um, right angles in it. So as I look here, this is an example of an oblique triangle. This does not contain a right angle. So there are a couple laws that were found to be true, and we'll talk about why this is true tomorrow. One of the laws is the law of sines, and it's based off this idea that we have a triangle here, and it works out that the ratios for each of the sides is if I take the sine of an angle over its opposite side, so sine of A over its opposite side, that ratio should be the same thing as the sine of angle B over its opposite side, which should be the same thing as the sine of angle C over its opposite side. And we will talk about more about this, why this works out tomorrow, but I just wanted to give you guys a beginning lesson about what it means. So we're going to be looking at two different types of triangles that we can use the law of sines for, and when you guys get back from vacation, we'll talk about another case in which it can be used. So let's look at this example here. I have an angle and an angle side. So what I usually do with these always is I just draw a triangle, and it doesn't have to be anything special. It doesn't have to be specific. So I have angle A, angle B, and angle C. And what I know is that angle A and side A are opposite each other. So if this is 48.3 degrees, then I know this is 39.4. And then I know that this is 94.5. And then this is going to be side B. And that's going to be angle C. And this is side C. Now I know for any triangle, all these angles need to equal 180. So when I did the math, and if I take 180 and subtract 94.5, which is angle B, and if I subtract 48.3, which is angle A, I can get angle C. And when I do that, I get angle C to equal 37.2 degrees. So that's pretty easy to find. So I found this angle of 37.2. But my goal is to solve the triangle. And if you guys remember, when I solve, that means to find all the missing angles and missing sides. So the first thing I want to do is I want to find side B and side C. So what I'm going to do is, just because I was given angle B first, let's find out what side B is. So the law of sines goes that if I know the sine of angle A and I know side of A, or the side A, and if I know the sine of angle B, I could take that over the side B. So in this case, I know what angle A is. That's 48.3. So if I take sine of 48.3 degrees and take it over the side A, which is 39.4, that will equal the sine of angle B, which is 94.5, over side B. And what we're going to do is, just in order to solve this, this is a proportion, so how do I solve proportions? By cross multiplication. So I will take B sine 48.3 and then 39.4 sine of 94.5. So what I'm going to do is divide both sides by the sine of 48.3. And what I do is, just to find out what B is, I'm just going to do 39.4 sine 94.5 over the sine of 48.3. I'm going to put that in the calculator because there's really no way that I can calculate this. And when I find out what side B is, I get side B to be 52.6 units. Okay? So I found this to be 52.6. Okay? So now what I want to do is find out what side C is. So I'm going to start off with the same idea that I know angle A and I know side A. So instead of B, I'm going to be doing sine of C over C. So I'm going to say the sine of angle A, which is 48.3, 39.4 is going to equal the sine of 37.2 over c. See, the reason why I have to do this is because this is not a right triangle, I can't use the Pythagorean theorem. I wish I could use the Pythagorean theorem because that's a heck of a lot easier than doing what I'm doing now. But because none of these angles are 90 degrees, I cannot use the Pythagorean theorem. So what I'm going to do is just solve it kind of like what I did there. Just cross multiply and divide. So I have what ends up happening is you get c to be 39.4 sine 37.2 over the sine of 48.3. And when I do the math, I get side C to be, I got it to be 31.9 units. Okay? So this isn't too bad. We're going to look at another case in which I'm given an angle, a side, and an angle. So let's draw this picture. It's not that complicated. This is number 4 in the notes. So I have A, I have B, I have C. So this is 42. This is 61. And then this is 65. So I don't have any angles and sides that are opposite each other right now. So what I'm going to do is find out what angle C is. So when I take 180 minus 61 minus 42, I get that missing side measure to be 77 degrees. So now, the only way that I can use the law of sines is if I have an angle and a side that are opposite each other, which I do. So I could take the sine of 77 over 65 and set that equal to, and let's just say we want to find out what side A is, the sine of 42 over A. So we'll cross multiply. I get A sine 77 equals 65 sine 42. And then you get A to equal 65 sine 42 over the sine of 77. And when I do the math, I get side A to be 44.6 units. I put that in the calculator. Make sure I put parentheses around the numerator and then divide it by whatever the denominator is of sine of 77. So I know what A is. I know that's 44.6 units. So now I just got to find out what B is. So I'm going to set it up the same way. I'm just going to say sine of 77 over 65 equals the sine, in this case, of 61 over B. So I get B sine 77 equals 65 sine of 61. So you get B to equal 65 sine 61 over the sine of 77. And when I do my math, I get B to equal 58.3. Okay? So what I want you to do is I want you guys to try to do question number 5 and question number 2. All right? In your notes, do question number 2 and number 5, and we will talk about those in class tomorrow.